Hi, so let's look at this question here, which is on parametric equation. Let's say we could do this proficiently. I believe this question was taken from one of the school tutorial RI, question 11. Okay, so the parametric equations of a curve where x is 80 and y is 80 square, where a is a positive constant, the points P and Q lie on the curve. Okay, so find a simplified expression for the gradient of the chord PQ. I think this is pretty okay. Now we can quickly just plot on the curve. I think what you get, A, we could just let it be any positive constant, let it be 1. So this is like tx and this is like t square, right? I think you'll get it's actually a quadratic equation, but make sure to understand that the window just change to -10 from negative infinity to positive infinity. The curve should look like something like that. Okay, so that's the first thing. So this case here shouldn't be an issue. Let's say I randomly pick a point P here. So this P has got the coordinates of parameter is actually P, right? So it has AP and AP square. Then Q is actually AQ and AQ square. Okay. So what we need to do here is to find the gradient of PQ of this chord here. Shouldn't be an issue. Gradient of the chord. So what we need is we need dy dx when it does actually dy dx no, we just could just find the gradient. The gradient is just gradient, a gradient of chord MPQ. We know that from second we know the gradient formula is just y1 minus y2, which is AP square, over x1 over x1 minus x2. Okay, great. So this is okay. Just simplify this. So what I get is a q square minus p square over a q minus p. Then the top, okay, just cancel these two guys here. Then what we get here is actually q minus p, q plus p over q minus p. So what we get, cancel these two up, we get p, q plus p. Okay, great. So we done the first one. Simplify the gradient of chord PQ. This is just simply that. So deduce this expression, the gradient of the curve at point Q. So from this expression, so how do we make sense of it? Okay, what you should understand is if you want the gradient of the curve at point Q, you should move P closer to Q, right? So let me just visualize this for you. So say now you have got two random points here. You just draw a chord, which is the gradient between P and Q. So we could fix P or Q, doesn't matter. So in this case here, let's say my P, I could just increase it, my Q, or this is my Q. Say if I want the, I fix my Q, so I don't move it, and then I just move my P over. Okay, so this case my Q can be a positive value here. Okay, great. So if I want to find the gradient at Q, what I need to do is I just need to move P closer to it. Okay, so much so that P becomes Q. So when P becomes Q, it will just be the tangent. That is what they want you to do. Essentially, the gradient of tangent at point Q as P goes to Q, okay, meaning the point P move to point Q, the gradient of the chord MPQ will tend to the gradient of tangent at Q. Okay, that's what you want. So the gradient of curve at point Q, there you go. So meaning P goes to Q. There you go. So this will be P just becomes Q. So we just want P becomes to Q plus Q equals to 2Q. That's the gradient of curve at point Q. So that's how we do this question proficiently. If you have any questions at all, please do let us know and I'll see you in the next question.